started. We're doing math today. So if you guys have your math packets, and then they look like this, I'm gonna have you get those out and turn to page 8. So page 8 in the math packet. Okay, so we're going to be talking about quadratic functions today. Yeah, on page 8 it says quadratic equations. So more specifically, we're going to be talking about like how to solve them. And then we're going to be talking about 2 types today. But first, let me just tell you a little bit about like quadratic functions. So like it says in the book, like this would be x squared plus bx plus c. This function is a quadratic function, and then you can tell because it has a 2, which is the highest degree. So quadratic functions have the highest degree of 2, and then their maximum roots, or like where they cross the x-axis, they can either cross it 2 times. It could be like where it crosses it 0 times, like that. Or it could cross it just like 1 time, like that. So that's not super important right now. But this is a quadratic function. And then the graph is a parabola, which is that curved graph, like that, parabola. So now we're going to talking about how to solve them. And the first way I want to talk about is factoring quadratic functions. So let me erase this. So if you look in your math packet, you want to flip to page 9. So there is an example, which is x squared at the top. X squared minus 7x plus 12 equals 0. So in the book, this equation is solved by factoring. And so it turned from this, if you look all the way at the bottom there, it became x minus 4, x minus 3 equals 0. We set x equal to 0, so x minus 4 equals 0, and then x minus 3 equals 0. And we solved for x. So basically, I'm going to teach you how we got from this to our answers, x equals 4 and x equals 3. Okay, so when we're solving quadratic functions by factoring, we want our equation to get in a form to look like this. So this is the form we want it to look like. And so our P and our Q kind of represent our answers. And so there's like 3 names for those. Those are called zeros because, like I showed you, that's where they cross the x-axis. They're also called roots, and then they're also called solutions. So P and Q represent my zeros, roots, or solutions. And these 3 words all mean the same thing. So now let's work on an actual example. All right, over here. Okay, you guys have this down? Sorry, I'm gonna write over here so it's bigger. Okay, so first example, let's say I have x squared minus 4x equals 45. And we want to solve this equation by factoring. So the first step would be to get everything over on the same side. So it kind of looks like that, ax squared plus bx plus c. So we want it to be in this form before we start. So what I'm going to do is subtract 45 from both sides. So that turns into x squared minus 4x minus 45 equals 0. And then from there, we're going to do something called morphing, which is how we solve quadratic equations by factoring. So I'm going to draw that over here. Hopefully you can see it. Okay. So basically, I draw a little cross. It's morphing. And so the M goes up here. A is at the bottom. We have an R at the side and then an F on the other side. And so what MARF stands for is multiply, add, rewrite, and then factor. So my first step is to multiply. What I do is multiply A and C. So if I look at this form, my A is the coefficient in front of the x squared, and C is that last constant. So I'm going to take x, this technically has a coefficient of 1 times negative 45. And then I'll write that up here. So that was negative 45. Okay. And so my next step is I want my two numbers that I'm going to find to add to B. And so B is the coefficient in front of x. And if you look at our example that we're doing here, it's negative 4. So I'm going to write negative 4 down there above the A. And then our next step is to rewrite. So I'm actually going to do that over here. But what we do, first we have to think of two numbers that multiply to negative 45 and add to negative 4. So can anyone think of two numbers that multiply to negative 45 and add to negative 4? Yeah. So my two numbers are negative 9 and 5. I'll write them over here in my little x thing. And so next step is to rewrite. So we start off with our x squared. We don't do anything with that. And then instead of negative 4x, we're going to replace it with those two numbers we found. So negative 9, we're going to add an x. And then plus 5x. So we replace negative 4x with negative 9x plus 5x. And then I'm going to rewrite my negative 45. Okay, and then equals 0. Okay, so the F stands for like factoring, and so the last step we're going to do is factor by grouping. So I'm going to put the first two in parentheses and the second two in parentheses. So we'll factor the first one. So is there anything you can divide out of both x squared and 9x? Does anyone know? So I can actually take an x out. I'm going to take an x out. And so that leaves me with x minus 9. Okay, and then I've got to factor my second one. So are there any numbers or variables that can come out of 5x minus 45? Do you have an answer?
5.
Yep, 5. And then so make sure it's a positive 5. And then what I have left is x minus 9. Okay, so then, because I have two x minus 9s, that's going to be one of my factored forms. And then the other one is the ones that are left out, so x and plus 5. So I'll write that in parentheses. And then lastly, I can set these two equal to 0. So I'm going to set x minus 9 equal to 0 and x plus 5 equal to 0. If I want to get x alone, what I do is add 9 on both sides. And so x equals 9, and then subtract 5 on both sides here, x equals negative 5. And so those are my two zeros, roots, or solutions for that quadratic function. Okay, did that kind of make sense? You guys understand that a little bit? Okay, we'll do another example, so hopefully it'll make more sense? Does anyone need this still? No? Okay. So let me erase this. Okay. So my next example is x squared plus 12x plus 35 equals 0. So again, we're going to use the marking way. So let me set up my two x's. Then it goes M, A, R, F. Okay. So can anyone tell me what the first step would be? Does anyone know?
Multiply.
Yeah, multiply. So what two numbers are we going to multiply? Yeah, A and C. So A is technically 1 and C is 35. So 1 times 35 is 35. And then for the adding, what number do we want it to add to? You guys remember? So it was B, which is 12 in our example. Okay. So next step is the R, add, we need two numbers that multiply to 35 and add to 12. So can you guys think of two numbers?
7 and 5.
7 and 5. So I'm going to write 7 here and a 5 here, and then I'm going to start rewriting. So remember we leave this first part alone, x squared. What we're technically rewriting is just the 12x. So that actually becomes plus 7x plus 5x. And then we rewrite the 35 plus 35 equals 0. All right, so next step is to factor by grouping. So I'm going to pair these two up, the first two and the last two. So what can we take out of x squared plus 7x? Yep, just an x. And then what we've got left is x plus 7. And then what can we take out of 5x plus 35? Yeah, just a 5. And then we've got x plus 7 left. So you should notice that these two in parentheses should always be the same. And then if they're not, you might have done something wrong. So you'll probably have to try and redo it. But this will become x plus 7. And then on the outside we have x and plus 5. So that's in my next parenthesis. Okay, and so lastly, to find our two solutions, we're going to set those two equal to 0. So what would our x's equal?
-7 and -5.
Yep. So x equals -7 and -5. Okay, so do you guys have any questions? No? Anyone? Anyone online have any questions? No? Okay. So I'm going to give you guys an example that I want you to try, and then tell me the solutions. Okay, so the question is, what are the values of x that solve the equation? So if you want to try that on your piece of paper, I'll give you a couple minutes, and then we'll go over it. Alright, does anyone need more time? No. Okay, can someone yell out an answer? Anyone?
-1.
Yep, -1, and then there's one more answer.
-2.
-2, yep. Okay, does anyone have questions on how we got that? Yeah, okay. We'll go over it quick. So, I already set up my marking. We want two numbers that multiply to 1 and 2, so that's 2, and then add to 3. So what are two numbers that multiply to 2 and add to 3?
1 and 2.
Yep, 1 and 2. So I'm going to do my rewriting. X squared plus 1x plus 2x plus 2 equals 0. Then I'll group these two, first two and the last two. An x can come out of the first one. So we've got x plus 1 left. And then a 2 can come out of the second one. So then we've also got an x plus 1 left. Okay. So my 2 are x plus 1 and x plus 2. If I set that equal to 0, x plus 1 equals 0. Subtract 1 on both sides, and then x equals -1. X plus 2 equals 0. I'll subtract 2 on both sides, and x equals -2. So that's how we solve this one. Okay. So next we're going to try one where the number in front of our x squared isn't a 1. So if I give you 2x squared minus 11x plus 12 equals 0, it's still the same steps. We're going to mark. So my m, instead of it being like 12 times 1, it's actually 12 times 2 this time. So we want a number that multiplies to 24 and adds to our number in the middle, which is -11. Okay. And so a number that multiplies to 24 and adds to -11, that would be -8 and -3. So next step is to rewrite. X squared I'm going to leave alone. Replace -11x with -8x minus 3x, and then plus 12 equals 0. Okay, same thing. We're going to factor by grouping. So what can come out of 2x squared minus 8x? Does anyone know? Yep, 2x. So that leaves me with just x and then minus 4. Okay, and then out of -3x plus 12, we can take out a 3. And that leaves me with, let me take out -3, sorry. That leaves me with x minus 4 equals 0. And so from there, these two are the same, x minus 4, so that's one of mine. The second one is 2x minus 3. So again, I'll set those equal to 0, and then I'll come over here and do it. X minus 4 equals 0. If I add 4 on both sides, x equals 4. My second one, 2x minus 3 equals 0. So first step would be to add 3 on both sides. And so 2x equals 3. X still isn't alone, so I'm going to want to divide by 2. And so x equals 3 over 2. So my answers are x equals 4 and x equals 3 over 2. Alright, so I'm going to give you guys one more example to do, and this time it's going to have, in front of my x squared, the coefficient won't be a 1, So it'll be kind of like similar to this one we just did. Okay. Alright, so I want you guys to solve this one. 4x squared minus 13x plus 3. Okay, does anyone need more time? Yeah? Okay. Alright, we're going to start to go over this one. So to start off, we want two numbers that multiply, we want to multiply A and C together. So A is 4, C is 3. So my number that goes here is 12. And then for A, we want B, which is negative 13 in our problem. Okay, so who can tell me two numbers that multiply to 12 and add to negative 13? Anyone? Okay, so actually it's negative 12 and then negative 1. So those will multiply to positive 12, but they'll actually add to negative 13. So I'm going to do my third step, which is rewrite. So come over here. 4x squared I'll leave alone. Then I'm going to replace negative 13x with negative 12x minus 1x, and then leave this alone, plus 3, equals 0. Okay? Next step is to factor. So out of 4x squared minus 12x, I can take out a 4x. So that leaves me with x minus 3. And then out of negative 1x plus 3, I can take out a negative 1. So that will leave me with x minus 3 equals 0. Okay? So these two are the same. X minus 3, I'll need to write it once. And then the other one is 4x minus 1. Set those two equal to 0. So come over here. If x minus 3 equals 0, x would be 3. And then if 4x minus 1 equals 0, if I add a 1 over, 4x equals 1, and then divide by 4, x equals 1/4. So my two solutions are 3 and 1/4. Okay. Does anyone need this? Okay, so we're doing one more example of these types of problems. And so I'm going to kind of format it like an ACT question. So it'll be multiple choice. So if you give me a second to write all the answers on the board. Okay, so here's my question. Which of the following is a root of the function f of x equals 2x squared minus 7x minus 4? And so I'll give you your options. Okay, so A is 1/2, B is -2, C is -1/2, D is -4, and then E is 1/4. So I'm going to have you answer the question, which in the question you have to solve that quadratic equation, and then choose A, B, C, D, or E. Okay, I'm going to start going over it, so I'll do it by hand. Let me draw my little X again. two numbers that multiply to -8 and add to -7. And so those two numbers would be -8 and 1. So I'm going to rewrite 2x squared minus 8x plus 1x minus 4. And then I'll factor by grouping. So out of my 2x squared minus 8x, I can take out 2x, which leaves me with x minus 4. And then out of my 1x minus 4, I can take out just like a plus 1. So that leaves me with x minus 4. So these two are the same. So I only need it once, x minus 4. And then my second one is 2x plus 1. Okay. And so then we'll set those equal to 0 and solve for x. X should equal 4 and -1/2. So what would the answer be? Which one?
C.
Yeah, C. So even though C doesn't have 4, the question said which of the following is a root. So it didn't say all the roots, it said a root. So my answer is actually C. Yeah, and I saw some of you guys pulling out your calculator. So a little hack like on the ACT, if you don't have enough time or you don't want to solve this, if you have one of these calculators, the TI-84 Plus, I'm not sure how the other ones work, but if you have this calculator, what you can do, if you turn it on, and press Y equals, which is that button in the top left corner. So into that first space, we're just going to type our function, 2x squared minus 7x minus 4. So I'm going to do 2, and then the x is that like little button that says like x, t, theta, n. Do you guys see that? It's like under the mode button. So that's where you get your x from. And then you'll square it. Minus 7x minus 4. So once you type that in, press graph, which is that left-hand button. And then remember I said that the roots were where it crossed the x-axis. So, okay. So my answers are going to be where it crosses the x-axis, and you can see that's crossing at 4, and it's also crossing at -1/2. But there may be some where you can't tell just by looking at it. So if you want to know the exact number, you're going to hit the second button, and then trace, which is the fourth from the left. And then it says like calculate or inequality, stay on calculate, and then if you scroll down to number 2, it says 0. So you're going to press that button, 0. And then they'll bring you back to the graph. It says like left bound, x equals whatever, and then y equals whatever. So whichever one, so there's 2 because it crosses the x-axis twice. Whichever one you're going to measure, you want to go to the left of it. So I'm going to go all the way to the left of my parabola, and then press enter. And then next down at the bottom there, it says right bound. So I'm going to go to the right side of my 0 on the parabola, and press enter. And now it says guess. So I'm going to get as close to where it crosses the x-axis as possible. And then press enter, and it'll tell you x equals 0.5, y equals 0. So that x equals 0.5 is the same as, -0.5. That x equals -0.5 is the same as my -1/2, which was one of my answers. And then, although 4 is a 0, it wasn't one of my answers. So that's how you would solve. And so then you'd be done. You don't need the 4 for your answer. So that's like a little hack. If you are short on time, you can use your calculator to solve these. Yeah, so you can use your calculator to solve these ones specifically. Okay, do you guys have any questions? No? Alright, so sometimes we have quadratic functions that we can't solve by factoring. Okay, so sometimes we have quadratic functions that we can't solve by factoring, and so we use something called the quadratic formula. It kind of looks a little scary, but I'll write it up here. Okay, so it's the quadratic formula is negative b plus or minus the square root of b squared minus 4ac, and then all over 2a. And so like the b's, the a's, and the c's, that comes from our quadratic function, which was that ax squared plus bx plus c. So we're still using like those a, b's, and c's, except now we're plugging them into this formula. Which is kind of scary looking, but it's actually not too bad. And I recommend, like, I would play like a YouTube video, but I recommend like when you go home or whatever, like looking up quadratic formula song, and that can really help you remember this formula. The one that I remember is like set to the tune of Pop Goes the Weasel, so that's how I remember this formula. But yeah, so if you could look up quadratic formula Pop Goes the Weasel, it'll come up a song, and then you can like play it on repeat, and then you'll never forget it. So we're going to use this formula to solve one of these functions. So I'll show you an example like x squared plus 3x minus 5 equals 0. So if I had this, technically you could factor to solve it, but we're going to practice not factoring. So to start, I'm going to like label my a's, b's, and c's. So a is that number in front of the x squared. There's nothing there, so it's technically a 1. My b is in front of my just the x, which is 3. And then c was that constant, which is negative 5. So a is 1, b is 3, and c is negative 5. And so from there, I'm just going to plug it into my formula. So we start off with negative b. My b is 3, so I'm going to write negative 3. And then plus or minus big square root b squared, so b is 3 again, 3 squared, minus 4 times a is 1, and then that times c, and c is negative 5. Okay, we're not done yet, and then we have to divide all that by 2 times a, and then a is 1. Okay, so now we're not done yet because this is all like just some big huge formula with numbers plugged in, but we want to simplify it. So I'm gonna leave my negative 3 out front because there's really nothing to simplify it with yet. 3 squared, I can change that to 9. 3 times 3 is 9. And then negative 4 times 1 times negative 5, which would be positive 20. And then all of that over 2 times 1 is just 2. Okay, so I'm going to simplify this even more, just a little bit. So I'm still going to leave my negative 3 out front, but I can add that 9 and 20 that are under the square root. So 20 plus 9 is just 29. Square root 29, and then over 2. Oh, sorry. I forgot to write the plus or minus. Okay, which was right here. I just need to bring it down. Okay, so that's my answer. Negative 3 plus or minus the square root of 29 over 2. If I were to like type that in my calculator, you get like a number that has like all these decimals and stuff. So it's easier just leave it like this. Negative 3 plus or minus the square root of 29 over 2. So that's like the solution to this. Okay, does anyone have any questions about that? No? Alright, so we're going to do another example. Okay, so equals 0. Okay, so first step is to do negative b. If you notice on this one, my b is already negative. So it's actually just going to become 6 instead of negative 6. Then plus or minus b squared. I'm going to like skip a couple steps. So negative 6 squared is just going to be 36. And then minus 4 times a is 1 times c is 4. So 4 times 4. And I'm just going to actually write negative 16. Okay. And then all of that over 2 times a. A is just 1, so I'm going to write 2. Okay. So next step would be to kind of like simplify this. So 6 plus or minus square root of 36 minus 16. I can subtract that easily. So 36 minus 16 is just 20. And then over 2. Okay. And so we could simplify, like take a 2 out of the 6 and out of the 2 down at the bottom. But actually, with our square root 20, we can simplify that down too. So if you guys have practice with simplifying square roots, there is a perfect square that goes into 20. You guys know what it is? So I can break this into square root 4 and square root 5. The square root of 4 is actually 2, and then square root of 5 can't be simplified anymore, so just square root 5. So I'm going to change my square root 20 into 2 square root 5, just to help me simplify things down a bit. So that equals 6 plus or minus 2 square root 5 over 2. Okay. And now that we're at this point, we can actually divide a 2 out of everything because there's a 2. We can divide a 2 out of the bottom, a 2 out of here, and then a 2 out of my 6. So if I take a 2 out of everything, that goes away and that becomes 3. My answer equals 3 plus or minus square root of 5. Alright, you guys see how I got there? Yeah? Okay, so this would be my answer to my starting equation, x squared minus 6x plus 4, using the quadratic formula. Alright, so now I'm going to have you guys try one on your own. So I want you guys to solve this using the quadratic formula, and then it's still up there if you need to see it. Okay, so I'll start going over this one. So negative b, technically there's a 1 in front here. So negative 1 is actually a positive 1. Plus or minus the square root b squared, so negative 1 squared minus 4 times a. My a is 5. And my c is negative 8. All over 2 times a, which is 5. Okay. So I'm going to start simplifying. Negative 1 squared is 1. And then if we have negative 4 times 5 is negative 20 times negative 8, that would be positive 160. So plus 160 over 2 times 5 is 10. Okay. So last step, I can still simplify some more. So I'm going to do 1 plus or minus 160 plus 1 is square root of 161. And then over 10. And then I'm just going to leave it like that. I'm not going to try and simplify it anymore. And so that would be my answer using the quadratic formula. Okay. So sometimes on the ACT it'll ask you a question like how many solutions a function has. And so we use something called the discriminant to find that out. And the discriminant was part of the quadratic formula. It's just that the part under the square root. So b squared minus 4ac. So we're going to use this to find something called the discriminant. It's actually, I think it's on page 8 in your math packet. So that portion of the quadratic formula is called the discriminant, and we use it to find out how many solutions or roots we had to our functions. And then, the type in the number. Okay. So say I give you x squared minus 6x. Actually, let's look at the math packets real quick. So on page 8, it says that b squared minus 4ac is the discriminant of the equation. If this portion is greater than 0, then we have 2 real roots, and then there's a graph on there that shows that it crosses the x-axis twice. That's what 2 roots mean. If our b squared minus 4ac is less than 0, it has 2 imaginary roots, which basically means that it's not crossing the x-axis. And then if b squared minus 4ac equals 0, that means there is 1 real root, which means it kind of like sits along the x-axis. So you could have an ACT question that says like it could say like how many roots are there to this one function, this quadratic function. And so we'll use the discriminant to find that out. So here's my example, x squared minus 6x plus 10 equals 0. So I'm not going to solve this, I'm just going to do that b squared minus 4ac part. So if I label all my parts, a was 1, b is negative 6, and c is 10. So b squared is negative 6 squared minus 4 times a is 1, and then times c is 10. Okay, so 6 squared, or negative 6 squared is 36. And then negative 4 times 1 times 10, that's just negative 40. So 36 minus 40 ends up being negative 4. That's my discriminant. And so if you look in your math packet, because negative 4, or because my b squared minus 4ac is less than 0, it's a negative number, what does that mean about this?
2 imaginary.
Yeah. So that could be like one of your answers on the ACT. It'll be like no real roots, or it could say like 2 imaginary roots. Okay, let's try another one. We're still going to be using the discriminant. So x squared minus 6x plus 9 equals 0. So I'm going to use b squared minus 4ac. B is negative 6 again. Squared. Minus 4 times a is 1. And then c is 9. Okay? So negative 6 squared is 36. Minus 4 times 1 times 9. That's also 36. So minus 36. Okay, so we've got 36 minus 36, which equals 0. So my discriminant is 0. What does that mean about this function? Yep. So that means that if we were looking at like an x or an x-axis, it would like hit once. Okay. So one more example. I'm going to have you guys do this one on your own. Just find the discriminant. But it's x squared minus 6x plus 8 equals 0. So find a, b, and c, and then plug that into b squared minus 4ac. Okay, so what does my discriminant tell me about the type of solutions?
There's 2 real.
Yeah, because my discriminant turns out to be 4, which is greater than 0, so that means I have 2 real roots. And again, you could like plug this into your calculator like I showed you and see like how many times it crosses. If it just crosses once, if it crosses 0 times, if it crosses none. I've seen like questions on the ACT where they'll ask you to like find the discriminant and it'll be like a number answer, or they'll ask you just like how many roots there are. So either way, you use the discriminant to like solve that question or solve those questions. Okay. So that's all I had for today. We have like 5, or I think your break starts now. Does it start now? Okay. Okay, so that's all I have today. Does anyone have any questions for me? No? Okay. If you're on Zoom, you're going to stay on this column, and Manoj and I are just going to switch rooms. So you guys can go on break now.
Lauren, make sure they're on the same screen. They don't move from.
Yeah, I told them to stay.
Okay.